So this is the first session of food analysis, advances in food analysis. So today we'll be starting with the overview of spectroscopy and chromatography. So before we start, we have some important definitions to consider. So what is spectroscopy? So study of light from an object is spectroscopy. So to do spectroscopy, we will need a spectrometer. So the instrument which spreads out light by making a spectra is called as a spectrometer. Now what is spectra? The range of electromagnetic energy separated by wavelength is called as spectrum. The study of the interaction between electromagnetic radiations and matter is called as spectroscopy. Now what is period? The time required for one cycle to pass a fixed point in space is called as period. Now what is frequency? The number of cycles which pass a fixed point in space per second is called as frequency. Amplitude is the maximum length of the electronic vector in the wave, that is the maximum height of the wave. Now what is wavelength? The distance between two identical adjacent points in a wave is called as wavelength. Wave number. The number of waves per centimeter in units of centimeter inverse is called as wave number. So what are the basics of light, electromagnetic spectrum and X-rays? Light can take on many forms, that is radio waves, microwaves, infrared, visible, ultraviolet X-rays and gamma radiation are all different forms of light. The energy of the photon tells what kind of light it is. Radio waves are composed of low energy photons. Optical photons, the only photon perceived by the human eye, are a million times more energetic than the typical radio photon. The energies of the X-ray photon range from hundreds to thousands of times higher than that of the optical photons. The speed of the particle when they collide or vibrate sets a limit on the energy of the photon. The speed is also a measure of temperature. On a hot day, the particles in the air are moving faster than on a cold day. Okay. Very low temperature, that is hundreds of degrees Celsius below the 0 degree Celsius, produce low energy radio and microwave photons, whereas cool bodies like ours, that is 30 degrees Celsius, produce infrared radiations. The very high temperatures produce X-rays. Okay. So as we discuss different parameters, that is the wavelength, amplitude with respect to the electric field are displayed into the diagram. That is, amplitude is the height and wavelength is the distance between two peaks. So what is electromagnetic spectrum? The arrangement of all types of electromagnetic radiations in order of the increasing wavelength or decreasing frequency is known as complete electromagnetic spectrum. The visible spectrum represents only a small portion of the electromagnetic spectrum. Infrared radiations have longer wavelength and are thus less energetic. Cosmic rays carry high energy while radio waves are least energetic. Microwaves has larger wavelength and are used in telephone transmissions. So overview of spectroscopy. Spectroscopy is the study of absorption and emission of light and other radiations by matter. It involves the splitting of light into its constituent wavelengths, which is done in much the same way as a prism splits light into a rainbow of colors. In fact, old style spectroscopy was carried out using a prism and photographic plates. The principle of UV visible spectroscopy is based on the absorption of ultraviolet light or visible light by chemical compounds, which results in the production of distinct spectra. Spectroscopy is based on the interaction between light and matter. When the matter absorbs the light, it undergoes excitation and de-excitation, resulting in the production of a spectrum. When matter absorbs ultraviolet radiations, the electrons present in it undergo excitation. This causes them to jump from the ground state, an energy state which is a relatively small amount of energy associated with it, to an excited state, which is an energy state with a relatively larger amount of energy associated with it. It is important to note that difference in the energies of the ground state and the excited state of the electron is always equal to the amount of ultraviolet radiations or visible radiations absorbed by it. So what is Beer-Lambert law? The statement of the Beer-Lambert law can be written as follows. When a beam of monochromatic light is made incident on a solution that contains a substance that absorbs the monochromatic light, The rate at which the intensity of the beam decreases along the thickness of the solution is directly proportional to the concentration of the absorbing substance in the solution and is also directly proportional to the intensity of the incident monochromatic radiations. As per the Beer-Lambert law, the greater the number of absorbing molecules, the greater is the extent of absorption of the radiation. Clear? UV visible spectroscopy. The ultraviolet and visible absorption spectroscopy is a type of spectroscopy which involves the calculation of the light beam attenuation after it passes through a sample or reflects from a sample surface. So what are the kind of detectors which are used in UV visible spectroscopy? A widely used detector in UV visible spectroscopy is a photo multiplier tube which is shown below. It consists of a photo emissive cathode, multiplying diodes and an anode. What are the different types of spectroscopy? Spectroscopy basically is integral to a variety of disciplines. While it provides a theoretical background to the early quantum research in radiation and atomic structures, it also has a staggering number of other applied uses which we will see in the next slide. The different types of spectroscopy are distinguished by the type of radiative energy involved in the interaction. In many applications, the spectrum is determined by measuring changes in the intensity or frequency of the radiative energy. The types of spectroscopy can also be distinguished by the nature of the interaction between the energy and the material. What are the different types of spectroscopy? Astronomical spectroscopy, absorption spectroscopy, biomedical spectroscopy, energy dispersive X-ray spectroscopy and many more. So what is astronomical spectroscopy? This type of spectroscopy is concerned with the analysis of objects in space. What is absorption spectroscopy? Can be used as a spectroscopic technique that measures the absorption of radiation in matter. Okay, biomedical spectroscopy is a type of spectroscopy that is used in biomedical sciences. What is energy dispersive X-ray spectroscopy? Is used for the identification and quantification of elements found in a sample. Okay, so that's all for this lecture. Thank you.